Hi everybody. So finally the wait is over and sorry for delay. The session got delayed because of some technical issues as well as because of this World Cup. You can say the Australia versus South of Africa, right? So the match was very close, but it's okay. It's fine. So I think my voice and everything is audible. So please confirm once so that we can start the season. So this is going to be a probability lecture number 3 and we are going to discuss many things today. So you might expect 1.5 hours of session for today, right? So uh, yes. So please start joining the session so that we can start it and we can have a great conversation right on this session, right? So today's session, what I'm supposed to discuss here is I talk about some of the probabilities laws, right? For you can say for discrete sample space as well as for continuous sample space. So there are two laws, and the second law will be quite strange to you if I would say that probability is going to be this from now onwards. For continuous sample space. So you will say that, sir. Yeah, it's a great it's a great concept, right? That you have told me, right? Okay. So we will talk about today basically some of the problems as well, right? And we'll talk about conditional probability as well. We'll talk about addition theorem on probabilities, right? So this is going to be lecture number 3 on probability. Okay. So we will take one single example. You can say and we will try to use the probability law here. Okay, that probability law is going to be basically called as discrete uniform law, right? So the probability law here I'm going to start now. Some of the important probability laws. Okay, for you can say for discrete you can say discrete uniform law. So this law is going to be useful for discrete sample space. Okay, and then we will talk about okay, so then we'll talk about one of the important law that is very new for you. I think that might be very new to you, right? So yes. So what is this discrete uniform law? So what we will do here is we will consider one sample space here, right? And we will consider that all elements are equally likely, we can say, right? So like just like you can say uh, though we have discussed this law already, right? If all the elements are equally likely, the probabilities are going to be same. Okay. So you can say that suppose this is going to be a sample space. Okay? This is a sample space. If all the elements are there, you can say these are the elements. You can say there are n number of elements, right? Okay, there are n number of elements, right? Okay, there are n number of elements and they are equally likely, you can say, right? So the very first point where we are going to use this uniform law is going to be what? The all outcomes should be equally likely. Okay, this is very important point that you have to remember. Okay, yes. So the very first point is what? The sample space consists of n equally likely outcomes, right? The sample space consists of n equally likely, okay, likely outcomes. Okay, and there will be one event, you can say there is going to be one event. See, if the elements are equally likely in the sample space, so can somebody tell me what will be the probability for any particular any particular outcome? Okay, suppose I want to find, see there are n number of outcomes in the sample space. Okay, if all the outcomes are equally likely, so can somebody tell me what will be the probability for single outcome? Okay, so that you can always talk about. So suppose I want to find what is the probability for this element. So you can say the probability is going to be 1 by n, right? I think everybody knows that. Okay, the probability of the particular event, you can say, is going to be 1 by n, right? Number of element in the sample space, number of element in the sample space, 1 upon number of element in the sample space. Okay, because the outcomes are equally likely. This is very important to keep in mind. And suppose there is one event called A, right? That consists of k element. Okay, Suppose there is an element, you can say there is an event A that consists of k number of elements, k elements. So this is very important. So A consists of what? A is kind of element, you can say, consists of k element. Okay. So suppose if I ask you what is the probability of the event A? What is the probability of the event A? So you will take always k times the 1 by n, right? This is going to be the probability. Okay, please remember this, and this is known as discrete uniform law, right? If the sample space is discrete, okay, if the space is discrete, understand? So we can consider all the outcomes are equally likely. The probability is going to be 1 by n number of element in the sample space. Okay, the classical definition of probability is going to be same, right? Favorable upon total, right? Favorable upon total. So favorable is going to be 1 only, right? Okay, if I want to find the probability of any particular you can say outcome, so 1 upon total number of. Understood? So this is very important to keep in mind. So let us take one very good example here, okay, to realize this law. Okay, so the example I'm just going to consider is this. Okay, so what is this example here is, the example says that suppose we have got two rolls of a tetrahedral die, right? So if you consider a tetrahedral die, right? Tetrahedral die, and you just do two rolling, right? Two times rolling, two rolls. So you can say that suppose this is going to be a rectangle kind of thing or a square. So X, the first roll. Okay, so you are going to get 1, 2, 3. You can say 1, 2, 3, 4, and you can say by is going to be a second roll, right? Second roll. Okay, so this is 1, 2, 3. 1, 2, 3, 4, right? So this is going to be your sample space, you can say. Understood? So if someone is going to ask you what will be the probability of each outcome, okay, so you can talk about what is the probability of this you can say square box. Can somebody tell me what will be the probability of each outcome? Please write in the chat box what will be the probability of each outcome. Okay, so there are 16 total outcomes, right? So probability of every possible outcome is going to be what? The probability of every possible outcome will be 1 by 16, right? So probability of an outcome, and say an outcome is going to be 1 by 16, right? 1 by 16. Why? Because all are equally likely, you can say all are equally likely, right? So if someone is going to ask you what is the probability of getting x equal to 1, what is the probability of getting x equal to 1? Yes, so getting x equal to 1 means what? Getting x equal to 1, if someone is going to ask you get probability of getting x equal to 1, right? So x equal to 1, how many times you are getting? What is that event? You see, identify the event. So you are getting one here, you are getting one here, you are getting one here, you are getting one here. So 4 times. So 4 times 1 by 16 is going to be the probability. So x equal to 1 is going to be what? X equal to 1 is the event. You can say event A, right? So probability of getting x equal to 1 is going to be what? That is 4 into 1 by 16, right? So this is how you can find out the probability, okay, using the probability law. So it is going to be what? 1 by 4. Okay, it is going to be 1 by 4. Now next question is what? Next question, suppose I'm considering new you can say suppose this is going to be x is the first roll and the second roll is going to be by. So what we are doing is we are rolling first die first. Okay, so we are going to get 1, 2, 3, 4. Again we are rolling second die, so again we are going to get you can say I think this is clear, right? So if somebody is asking that, suppose we have got one event here, z is equal to minimum of x comma by, z is equal to minimum, this is new event, you can say some sort of a event here, this is the new event, z equal to minimum of x comma by. So what is the probability that z is equal to 4? What is the meaning of that? What is the probability that z equal to 4? They are asking, right? What is the probability that z equal to 4? So this is very good question, in fact, right? This is going to be a very good question. Okay, so when you can get z equal to 4? Okay, when you can get z equal to 4? See, if z is nothing but what, you can say that just make one table here, x and y, right? X and y. So suppose x is 1 and y is also 1, you can say. So you're not going to get, like, you will get minimum what, 1 only, right? Suppose 1 x is 2, right? And y is 2 also, right? So what you will get here, minimum is 2 here, right? Or you can say that y is 3. So minimum is what, z equal to minimum of x comma y, right? So here if you take like this, z equal to y equal to 2, z equal to this 3, 3, 4, right? You can take any combination, right? So this is going to be situation, yeah. So x and y, so what is the minimum here? Z is going to be 1. Okay, in this case, what is going to be minimum here? What is going to be minimum here? It is going to be 2 only, right? And z equal x equal to y and y equal to 4, so z minimum is going to be 3. Right? Understood? So what is going to be the probability? Anybody? Can somebody tell me what will be the probability here? So I think anybody can tell here what is going to be the probability. Only one favorable outcome is there, right? Where you will get 4. Okay. Other than that, you will not get 4. Okay. See, if both the roll, you can see in both the throw, you are getting 4, 4. Okay. So if you are getting 4, 4 here, you can say 4 and 4, then only you will get 4 here. Otherwise, you will never get 4. Okay. Because this is the new event which is z equal to minimum. So the answer will be 1 by 16 only. 1 by 16. Understand? So if someone is going to ask you, suppose you have thrown 2 times the tetrahedral die, right? And they are asking what is the probability of z is equal to, or you can say that probability of minimum x comma y, right? So the answer is going to be 1 by 16, right? I mean, if this is going to be 4, right? Okay. So this is very important to keep in mind, right? This is going to be very important. And suppose they are asking what is the probability of z equal to 2. So now I think you guys can solve this question, right? The probability of z equal to 2, what is that? So again, you can refer this table. So z equal to 2, when how many times you are getting here? How many times you are getting? So if x equal to 2 and y equal to 3, okay, x equal to 2, y equal to 4, you will get 2 only, right? Okay, that you can see from the sample space. So how many times you are going to get probability of like z equal to 2? And how z is defined, that you have to remember. Z is defined by z is equal to minimum of x comma y. Okay, so what is the probability here for z equal to 2? How many times you are going to get? Okay, that you have to think. Okay. So can somebody tell me here how many times you will get? So you can go to sample space right here. So z equal to 2, okay, means at least one of the outcomes should be 2, right? So you can say that and this is 2 here, right? You can say this is 2 and this should be 3. Okay, so you can say this, okay, and then this is going to be here, yes. Okay, then if one of the outcome is 2, right? And you can also say that if this is 2 here, right? Okay, and you can say that this is going to be yes. Y can also be 2, right? So you will get z equal to 2. So 1, 2, 3, 4, and one more outcome will be there. Okay, you can think about it, right? So which one is that? The same, you can say, right? Yeah. So how many times you're getting, guys? How many times? You can say that the answer will be what? Probability of z is 5 into 1 by 16, which is 5 by 16. Okay, 5 by 16. So I hope everybody understood this question. So I'm just going to summarize this question. This question is very good question. Okay, remember. So let me again summarize. Summary here is what? Summary here is, suppose you are throwing 2 dice. Okay, okay, in 2 times you are ruling, right? 2 rows are there, okay, of tetrahedral die. Now, so you can get the sample space quickly here. So this is going to be a sample space, right? Or better, what you can do here is I can give you the sequential description also. So that will give you better situation, right? You can think about. So suppose these are the 4 outcomes in the first rule, and again you will get 4 outcomes, you see, right? Yes. So now you can think about it. So the 1, 2, 3, 4. Again 1, 2, 3, 4. Right? I mean, you can write this. Okay. So what is this? This is 1, 1. This is going to be 1 and 2, right? And this is going to be 1 and 3, 1 and 4. Right? 2, 1, 2, 2. Right? So you can think about it now, right? You can think about it. So if someone is going to ask you what is the probability of getting x equal to 4, so it will be only 1. See, these are not considered, okay, because 1, 2, 1, 1, 1, 2, right? So you will get here 4 and 4. So only 1 by 16 will be the answer. And suppose new event is defined like minimum of x comma by, okay. So suppose they are asking what is the probability of getting x equal to 4, right? So x equal to 4 they are asking, right? So x equal to 4 is nothing what that is the event, right? That is the event. So in first row you can say, in first row you're going to get 4, x equal to 4, or you can say, sorry, z equal to 4 here. So z equal to 4 means what? X and y both should be 4, then only you can get. So answer will be 1 by 16, right? So for this and for this, answer is gonna be same. Suppose they are asking z equal to 2. So now the twist comes into picture, right? अब twist आ चुका है आपके उसमें. Twist क्या आ गया यहाँ पर कि आपको फाइंड करना है कि how many times z equal to 2 is occurring. What is z equal to 2? It is nothing but minimum of x and y. You can say that 2, 3, okay, 3, 2, okay, 4, 2, right? Okay. You can say that I think this is clear, right? So 1, 2, 3, and you can say that 2, 4. Okay. This is one possibility here, right? And I think one more possibility you can say 4, 4, right? Sorry, not 4, 4. You can say 2, 2. They can be same also, right? So how many favorable outcomes are there? 1, 2, 3, 4, 5. You can say that 5 by 16 is the answer. So I think this is clear for all. How many of you understood this problem? So this kind of problem you might expect in your GATE examination. Guys, this problem is not from any normal university. This problem is I have taken from Massachusetts, MIT, US, right? So remember, this problem is not that simple problem, but I made it simple. ठीक है? ये बहुत इजी प्रॉब्लम हो जाती है क्योंकि लोग इसको ही समझते नहीं है. व्हाट इज दिस z इक्वल टू मिनिमम x कॉमा बाय. ऑलवेज रिमेंबर दीज आर इवेंट्स, ओके, एंड प्रोबेबिलिटी इज कंप्यूटेड फॉर व्हाट? प्रोबेबिलिटी इज असाइंड फॉर द इवेंट. Okay, probability is going to be assigned for the event. So this is very first, remember, this is going to be a very first law, okay, law of probability for discrete sample space, right? Let us take the probability law for continuous sample space, right? Okay, so suppose we have a, okay, so now we will see here probability law for continuous sample space. Okay, so people who are from electronics and communication background, who are going for GATE and along with this DA paper as well, so these sessions will be very helpful for them, right? Because they will be dealing with the communication system, so they should know these laws, right? Okay, so in fact for computer science also, so data science means any paper you can take, right? All the questions you will be able to do. I will tell you some important steps, okay, which is always involved, okay, while solving the probability question. Those steps you have to follow. So first of all, let me introduce this continuous sample space, probability law for continuous sample space. So let me consider one sample space, a very good sample space we are going to take. Suppose there is a sample space, you can say x comma y such that okay, such that x comma y, it is greater than 0 and it is less than 1, you can say, right? So here the sample space is defined as x can take 0 between 0 and 1, right? Okay. X and y can take 0 and 1 value, right? So here what probability law we are going to use? What probability law we are going to use? One of the very important law, guys. In fact, I always, this law I came to know in 2014, guys. Let me tell you. Right? In 2014, when GATE result was announced, okay, and let me tell you the month also. It was the month May month. Right? One of the though I was not I was not familiar with this law. Basically, I was using formulas and all, but if somebody is senior enough and he has a lot of experience, so he can tell better. So one of my cousin is there, right? He's currently working at Samsung, like as a technical leader, right? Having 7 years of experiences. So what he did was he told me that I asked him ki, how you have done this question, basically, right? I was not able to solve those kind of a questions. So he said, Dheeraj, actually this is this concept, right? What I'm going to introduce you. So those days I was like, oh, but now since I'm teaching probability here, so now I get triggered because of those things. Yes, we were not knowing those things, right? That's why we face a lot of problem, right? So before solving any problem, you should know the concept, okay? Without knowing the concept, never try any problem. That is a crime, guys. Okay? Because what you will do, you will try the problem and you will look at the solution. You will try the problem. So looking at the solution means you're losing gray cells, right? So and that is very important. So suppose this is going to be a sample space, okay, and now the new law which I'm going to introduce here is from now onwards, this is known as uniform probability law. Okay, uniform probability law, okay, and this is only applicable for continuous sample space. And from now onwards, keep in mind the probability is going to be what? Probability is going to be equal to area. Suppose you want to find the probability of any event happening inside the continuous sample space, so always keep in mind this probability is equal to area. That's it. Okay. See, when I will talk about random variable, okay, at that point of time also, I will talk about all the time area as far as the random variable is continuous random variable, right? Okay, so remember from now onwards, okay, if the sample space is continuous, or you can say random variable in future is continuous, so the area probability will be basically an area. Whenever you will try to find the probability of any sort of event happening inside the sample space, so you have to talk about area. And area means what? Area. I think everybody knows what is area, right? So area is nothing but integration in mathematics, right? Area is nothing but integration. Suppose some family of geometry is given, okay, and you have to find the area, so you can quickly find out, like area is given, sorry, triangle is given, right? So you can quickly say that, yes sir, triangle is nothing but, okay, I think this is clear. Okay, so triangle is nothing but what? Area under the triangle, area of the triangle is half a base into height. Rectangle is there, square is there, right? So you guys can find out area. But suppose you're not able to find the area, then you have to use the integration concept. That's it. Okay, so from now onwards, you can write in your notes, probability is going to be an area for continuous sample space. In future, that will be known as, like, for continuous random variable, the area is going to be the probability. Yeah. Chalo. So this is the law that I wanted to talk about today. So let me draw this this sample space first, right? So what is this sample space, guys? 0, x and y can take these two values, between these two values, right? So you can say that this is x and this is y. Okay, now x is nothing but 1 here and y is also 1. You can say that this is going to be the intersection point. right? This is going to be intersection point. Okay, so what they suppose they will ask question here, what is the probability that x plus y is less than 1 by 2? Suppose they are asking this question, what is the probability that x plus y is less than equal to 2, right? So guys, remember, we in case of continuous sample space, we always define events using some inequalities, right? Greater than or equal to, or less than or equal to, or strictly greater, strictly lesser, right? We never define event is equal to particular, right? Okay, x equal to, you can say x equal to 2. We never define this kind of a event, right? Because the probability of x equal to 2 in case of continuous sample space is going to be 0 always. याद रखना, अगर मान लो continuous sample space दिया है, in future you will see that if continuous random variable is given, so if you want to find the probability of x equal to 2, right? So there will not be any area. What is the area of the point, right? What is the area of the point? Area of the point is going to be what? 0, right? So whenever they will ask you probability of x equal to something at some particular value of the event, so the probability will always be 0. You can directly say the probability is gonna be 0. I think this is clear, right? So they will always ask the probability of x plus y far less than 1, you can say less than 1, not far, right? So what is this x? So you have to find this. Now what is this x plus y equal to 1 by 2? First of all, you take this x plus y, you try to plot here on this sample space, right? Try to plot. So this is nothing but what? You can say that y equal to minus x plus 1 by 2, right? So it is nothing but a straight line, okay, passing through, having negative slope, and it will pass through minus 1, you can say 1 by 2, 1 by 2. So you can say this is going to be a event I'm talking about, right? Okay, this is the event I'm talking about. And what kind of event is this? X plus y should be less than or equal to half, means this is the event. So we want to find the probability of this event. You can say 1 by 2 here, 1 by 2 here. So can somebody tell me what is the probability of this event? Anybody in the chat box? Knowing that the probability law, ये चीज आपको कोई नहीं बताता है मार्केट में. आप देख लेना यूट्यूब में, जितने भी यूट्यूब चैनल है, these concepts are not taught anywhere properly. I'm telling you, वही गेट की प्रॉब्लम उठाएंगे, उसी को सॉल्व करेंगे, राइट? So before you attack to the gate problem, first of all try to understand the concept. ठीक है? Gate is problem is very simple problem, guys. The concept we are discussing is very industry demanding concept, right? जो इंडस्ट्री में पूछे जाते हैं. So can somebody answer this question? Yes, I think people are active here. After a long time we are conducting this session, so I think yeah. So what you can do here is, yes, so you can see here what is the area of this guy, right? X plus y is going to be, this is the event A, you can say, right? Event A. So this is the event, and they are asking what? They are asking the probability of this event. Probability of this event is what? We need to bring the concept of area. What is the area of this triangle, guys? Area of this triangle is going to be what? 1 by 2. Height is, you can say height is 1 by 2 only, and the base is also 1 by 2. So answer is 1 by 8. Right? This is very, very important concept. Okay, so many people face a lot of problem, but now you guys will be able to solve this question, right? Okay, so this is one of the very important concept that I want to talk about. Suppose they are asking the probability of, let me take one more question here. Suppose they are asking the probability of 0.5 and 0.3, right? Suppose they are asking the probability of this event, right? Probability of 0.5 and 0.3. So this is 0.5, you can say x equal to 0.5, and 0.3 can be can be here somewhere. So this is the intersection point they are talking about, 0.5 and 0.3. What is the probability of this event? Can somebody tell me here? What is the probability of this event, 0.5 and 0.3? They are asking the probability of at a point, at a particular value, right? So what is the area of this point, right? That point is nothing but what? It does not have any dimension, okay? If something does not have any dimension, means the area is gonna be 0. So answer will be always 0, right? So no wonder. In fact, you don't have to take a look at sample space and all. Okay. So please remember, आज से याद रखना कि probability is nothing but area for what? Area for continuous sample space. Okay. So what are the steps that we need to follow? Okay, while finding the probability, right? So probability calculation steps. Probability calculation steps. Okay. So number one is nothing but you need to specify the sample space. You need to specify what? Specify the sample space. First, specify the sample space. Second, you need to specify the probability law. So depending upon the sample space, you can specify the probability law. Okay. Probability law. Okay. And the third one is going to be identify an event of interest, right? So the moment you define the probability law, right? देखो सबसे पहले माइंड में क्लियर होना चाहिए कि what will be the probability law here. If discrete sample space is given or discrete random variable is given, in future you will come to know, right? तो आप निकाल सकते हो, ठीक है? यहाँ कोई फॉर्मूले का यूज नहीं करना है, बस कॉन्सेप्ट यूज करना है, राइट? And then you have to specify the event of an interest. Okay, what you have to do? Event of an interest. Event of an interest. Event of an interest, right? And then you have to calculate the probability, right? Calculate the probability of event. जो भी event आप specify. These are the 4 steps that we follow in case of while computing the probability, right? Many people do not know about this. I think आप लोगों को भी नहीं पता रहा होगा, ठीक है? आप लोग बस प्रॉब्लम देखते हो, उसको में लग जाते हो, कॉन्सेप्ट पता नहीं है, राइट? तो मेरा मेन काम क्या है कि आई नीड टू इंट्रोड्यूस दोस काइंड ऑफ अ कॉन्सेप्ट वेयर यू शुड नो द कॉन्सेप्ट फर्स्ट, राइट? ओके, ये चीज मेरे केस में भी थी व्हेन आई वाज स्टडिंग. So I never self-realized that I am good at this subject, on this subject, right? I never realized that. How can I perform well in the GATE examination, right? कोई अगर आपको पढ़ा देता है, it doesn't mean that कि you are done, right? You need to self-realize, okay? And you need to develop your own problem-solving skill, okay? तो ये as a point, you can say as a student point of view, I always teach. आपको पता है कि the way I teach is just like the way student think, okay? तो आपको कैसे सोचना है उस टाइप का मैं पढ़ा रहा हूँ, ठीक है? तो each and every step has to be considered properly, ठीक है? So these are the very important steps that I have told you, ठीक है? तो I hope this makes sense. आपको समझ में आ गया होगा क्या होगा probability. अगर कोई पूछता है what is the probability of x plus y, suppose ऐसा कोई पूछता है what is the probability of x plus y greater than 1/2, ठीक है? क्या हो जाएगा? तो इसमें क्या करोगे? So you have to say that probability of x plus y greater than 1/2 is nothing but 1 minus the probability of x plus y less than 1/2, right? ठीक है? Greater than 1/2 means what? Probability cannot be greater than 1. So 1 minus. So it is simple. Answer आ गया, देखो. It is nothing but 1 minus 1/8, which is nothing but 7/8. Okay? And probability of, remember, okay, probability at particular value, right, is going to be 0 in case of continuous. In case of continuous sample space, okay, sample space. In future you will come to know that in case of continuous random variable. I hope this makes sense to all, right? So you guys have understood this concept, right? इसको याद रखना, okay? This is very, very important. One more concept will come into picture. One more concept here. A basic mathematics we are going to use here. That's it, right? You see here, what is that concept, right? So suppose we have got a sample space which is discrete, right? a sample space which is discrete, but the, you know, infinite outcomes are there. You can say sample space is infinite, right? So you can get this kind of a situation also. Sample space we are going to consider here, you can say discrete, but sample space is infinite. Infinite, okay, infinite. In future you will see the problem also, right? When you will get this kind of a situation, suppose they are saying that what is the probability of getting head, like how many tosses you're going to do, right? How many tosses, like how many times you will toss the coin until the first head occurs, right? Until the first head occurs, you don't know, right? You don't know when head is going to occur, right? So you have to toss the coin infinite times, right? Many times you will toss. First toss, no head. Second toss, no head. Third toss, no head. Fourth toss, no head, right? So you have to toss, you have to keep on tossing, right? So until the first head occurs, right? What is the probability of getting head, okay, for the first time, you can say. Okay, so in this situation, what will happen? You will get the sample space like tail, 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 head, or tail, 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 continuous, like this, okay? So this is very important to keep in mind, okay? So there will be case one, like you got tail, in the second toss you got head. Second case, tail, tail, head. Third case, tail, 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 head. Fourth case, right? So you will get many cases, right? So this is very important. This is one of the very important mathematics background also you need to know, right? So these kind of problems are known as GP based problem. GP, I think many of you might have heard about GP, right? Okay, geometric progression based problem, right? Whenever there is a sample space which is infinite. Okay, so discrete but sample space is infinite. What is the problem here? Suppose sample space is like this. Sample space like this. 1, 2, 3, and so on. Infinite. Okay. You can use the curly bracket, guys, okay, instead of using these curly bracket. And they have said that the probability of n, they have specified the probability of n. They have already given you some formula here. The probability of n is given as 2 to the power n for n equal to 1, 2, and so on, right? So there are probability of n is going to be what? 1 by 2 to the power n. Suppose n equal to 1, if it is 1, right? So probability of 1 is going to be 1 by 2, right? And probability of 2, you can say, is going to be 1 by 4. Probability of so probability is decreasing here, you know, as n is increasing, right? So you can plot also this p of n is equal to 2. Okay, so this is given in the question, right? This is given in the question. Okay, if someone is going to ask you what is the total probability, suppose somebody is asked what is the total probability. Okay, so probability should be always 1. So how you will do? You will go for summation, right? Because the sample space is discrete here. So you will start from n equal to 1 to infinity, 1 by 2 to the power n. So you will get 1 only, right, here. If you try to find the total probability here, right? Because if you add all, you will get 1 always, right? I think this is clear. So you can plot it also. The plot will be like this. Probability of n, right, versus n. So here you can say n equal to 1. So this is 1 by 2. Then this is going to be 1 by 4, n equal to 2. Then 1 by 8, and so on. It will be decreasing, right? Okay. Now, suppose they are asking what is the probability of outcome is even. Suppose they are asking this. And they have given the sequence of outcome 1, 2, 3, 4, 5, 6, and so on till infinity, right? And they have also given the how to find the probability of each outcome, right? So for n equal to 1, probability is going to be 1 by 2, right? So, you know, for corresponding outcomes, the probability is specified here using some formula, right? In the question they will mention, right? Okay, there will be some hint so that you can find the probability of each event, right? Suppose tail is there, so probability of getting tail is 1. Probability of getting head is, um, probability of getting tail is half. Tail and head is half also, right? So in this manner you can find out, right? So probability of outcome is even, means what you have to find here is probability of, okay, probability of 2, 4. What is even here? Even means you can say that 2, 4, 6 and so on, right? So I think this is clear for all, right? This is clear for all. And as long as this is nothing but what? Here we can consider the basics axioms which we have seen, right? So we can write this as probability of, okay, probability of 2 union the probability of 4 union the probability of 6 union, right? Like this and so on. So we can write this as, from the fact we know that suppose all events are disjoint events, so probability of A union B, okay? Probability of A union B is going to be what? Probability of A plus probability of B. Okay, if the events are disjoint events. So here we can consider these events are disjoint events, right? So we can use the additivity, okay, like we can use the additivity axioms, right? So it will be probability of 2 plus probability of 4 plus and so on. What is the probability of 2? Probability of 2 is nothing but 1 by 2 to the power 2, 1 by 2 to the power 4, 1 by 2 to the power 6 and so on, right? Probability of outcome is even. Okay. Now, how can you solve this? So you need to understand this, right? So you can take 1 by 4 common, right? So let me solve this. 1 by 4 common you can take, so 1 plus 1 by 1 by 4 plus 1 by 4 to the power 2, right, plus 1. So 1 by 4, and this is nothing but 1 minus 1 by 4, okay, from the GP, right? Because that is GP basically, right? I think everybody knows how to solve GP, right? So this is 1 by 4 into 3 by 4, right? And like 4 will go up, so 4 by 3, which is nothing but 1 by 3. So this is the answer for this question. Okay. So this is how we have to solve the question, right? So properly, if you don't know the concept, if you don't know those basic truths that I have told you, right, you can't solve it, right? So in fact, when word problem will be given, so you have to frame the cases, case 1, case 2, case 3, and if that is a GP based problem, you just keep on doing, right? These n value will be like number of heads in the first toss, number of heads in the second toss, number of heads in the third toss, because you have to keep on tossing until, see, coin is tossed randomly until the first head occurs. मान लो ऐसा क्वेश्चन आता है, coin is tossed randomly until the first head occurs, right? What will happen in the first toss? One head might occur. In the second toss, third toss, fourth toss, right? So you have to see, okay, until the first head occurs, or okay, this is very important to keep in mind. So GP based probability will be asked in your exam also, right? एक क्वेश्चन भी आया था 2012 में GP based problem, right? Where you have to get this GP and then you can use the GP concept. I think geometric progression everybody knows. Okay, what is geometric progression? If those who are not familiar with geometric progression, they can just revise it. Okay, understood. So already we have seen the countable additivity axioms, right? So that will strengthen the finite additivity axioms, right? Suppose you can think about this, why I have written like this. Okay, you might be thinking, sir, why you have written these two steps. Okay, so you can say that, I mean, this step how I have written and this step. So here I'm going to give you the theory behind that. Suppose you have got a sample space, or let me take some small sample space. Okay, this is the sample space. You can partition the sample space with different like this, A1, A2, A3 and so on till infinite, right? Okay, so if A1, A2, A3 is infinite sequence of disjoint event, you can, right? If A1, comma A2, comma A3 dot 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 is an infinite sequence, is an infinite sequence of disjoint event. Okay, I think many people might be familiar with disjoint event here, right? Because मैंने आपको basic truth बताया है, that basic truth you have to always believe, right? That's true. So disjoint, this is very important. Okay, so you can say that sequence of disjoint events, right? Then suppose they are asking, then the probability of A1 union A2 union A3 and so on till infinity is going to be equal to sum of the probabilities. Okay, as long as it is infinite, sequence is infinite, but you can count here still, right? 1 2 3 at least. Okay, some of the event you can say, yeah. So this is nothing but a countable additivity axioms, right? Okay, so here so many events are there, right? Okay, A1 A2 A3 infinite sequence of the disjoint events are there. Okay, so please remember, this is very very important to keep in mind. Okay, so you can say this is nothing but a mathematical importance. I mean, you need to know this, right? And area is one of the legitimate probability law for, you know, for continuous sample space, right? So this is very important to keep in mind. I hope this makes sense to everyone. So keep in mind, probability is nothing but what? Probability is nothing but description of beliefs. Okay, that something is going to happen in your life, right? So you can also find the probability of getting success in your GATE examination in DA paper after attending my classes, right? So probability is nothing but description of belief. So anybody, any sort of doubt here, please let me know, guys. This is what I wanted to talk. ये थोड़ा सा काफी अच्छा कॉन्सेप्ट है जो आपको याद रखना है. So please remember these concepts. These concepts are very very important to keep in mind, right? Okay, so if the events are mutually exclusive, so if they are asking what is the probability of at least one of the event has to occur, so you can just add probability of A plus probability of B, right? Okay, in this manner you can do. Okay, or you can say if there are n number of events and all are mutually exclusive. Okay, so you can say that. So mutual exclusion, what mutual exclusion is going to help you, right? It is going to only makes, you know, what, the probability calculation each year. Okay, that is very important to keep in mind, right? Okay, so I think this is clear. And if the events are not mutual, you can say they are not mutually exclusive. It means you have to go for what, inclusion and exclusion principle, right? Like probability of A plus probability of B minus whatever you have, two times you have over counted, so you have to subtract one time, right? The common probability. Okay, that is very very important to keep in mind. So inclusion and exclusion principle I have discussed for 2 events, for 3 events, right? And you can also discuss for n number of events, no problem at all, right? How many of you understood this concept? Please tell me first. So I hope this makes sense to all, right? So what next I'm going to talk about is what next, right? So yes, so I'm not giving you any sort of you can say any sort of formula here, because I don't encourage people to use formulas. I encourage people to use what? I encourage people to use concepts, right? Fine. So let me take some problem here. I mean, some concepts. So now, guys, I'll talk about types of events. Already we have discussed some types of events. So mutually exclusive events and disjoint events, right? Already we have discussed some sort of events, right? But now I'll talk about types of events. Then we will talk about conditional probability, because conditional probability is one of the very important concept. Okay, like having initial belief. Can you revise your initial belief, right? Okay, and you can do something new, right? Okay, तो रिवीजन ऑफ इनिशियल बिलीफ इवेंट्स, राइट? मतलब आपके पास, आप ऑलरेडी जानते हो कि आपका गेट में होने वाला है, ठीक है? अब आपको पता है, इसकी प्रोबेबिलिटी पता है कि यू आर गोइंग टू गेट गुड रैंक इन गेट एग्जामिनेशन, राइट? अब आगे की कंडीशंस अगर कुछ हैं, राइट, बेस्ड ऑन दिस यू कैन फाइंड द प्रोबेबिलिटी ऑफ फ्यूचर आउटकम्स, राइट? तो ये बहुत इंपॉर्टेंट है. जैसे कोविड में, already COVID happened, some data got collected, right? Now we have got some data, right? Okay, so now we can condition कि हाँ future में क्या होने वाला है, right? So that is the idea of conditioning. So conditioning is one of the important concept that we shall talk about, right, after discussing the type of events. Okay, so in fact I will just mention here what are the topics that I will be discussing in case of conditioning, as well as okay, so there will be only two concepts, remember. The conditioning chapter, when we will talk about here conditioning, okay, this chapter is named as conditioning. Okay, conditioning. And one of the very important rule, we call it Bayes rule. Okay, Bayes rule. Okay, and I will tell you where you have to use Bayes rule, where you have to use one important tool, that is nothing but total probability theorem, right? So under this conditioning and Bayes rule, we are going to talk about conditional probability. Conditional probability. Okay. Like people say now, thank you for unconditional support, right? There is no condition at all, right? There is no unconditional means what? No condition at all. Suppose your father is having affection to you, there is no condition at all. They don't expect from you, like you should take care of them, then only they are going to love you, right? What they are going to do here exactly is, there is no condition. But if there is a condition, means conditional, I think everyone understand. If there is a condition, okay, so the same similar story, similar concept we are going to use. Okay, okay, like in my case, I said to you, right, I'm going to share the assignment, there is some conditions, right, terms and conditions. Okay, so now we are going to condition the situation. Okay, I'm going to condition the event here, right, and I'm going to condition some initial beliefs that you have. So if probability of finding any event is the initial belief, and having that initial belief, we are going to find the probability of next event, right? Okay, so I will tell you one of the very important concept, right? So here I will talk about conditional probability, but how we are going to understand this conditional probability, there are some important tools. Okay, and these tools, guys, are the summary of probability theory, right? अगर आपको ये तीन टूल समझ में आ जाते हैं तो आपकी लाइफ में सबसे बड़ा अचीवमेंट है. Okay, in fact 50 lakh rupees is also not a big achievement for you if you understand these three important tools. जैसे मैं कोई टेक्निकल सब्जेक्ट पढ़ाता हूँ, तो always I try to specify some of the important fundamental tool, okay, that can help you answer any kind of question. मतलब एक generalized tool है. Okay, these are the generalized tool. Okay, you can say. So where these tools are going to be used? So these are the three important tools. Okay, there are three important tools. Okay, to understand to understand this conditional probability, the first is nothing but the multiplication rule. Okay? Multiplication rule. The second is nothing but what? The second is nothing but total probability theorem. We call it TPT. The total probability theorem. Now you will say by to formulas, whatever formula you have been writing till now because of many teachers, right? Because of your college teacher or any tuition teacher or college, any teacher, right? They always expose you, oh my God, 1 inch long formulas like this, 1 inch long formula. How can you remember those formulas, right? मतलब formula याद करना बड़ा tough है, right? If you have the sequential descriptions, you can all write those concepts directly, right? You can directly use the multiplication rule and you can write the formulas, but you can't remember the formula, right? So अगर आपको मैं कोई problem को बोलता हूँ कि solve these problems, you always go for divide and conquer rule, right? Divide the problem into different stages and try to solve them step by step. जैसे मान लो आपको you have to buy, you have to buy what? You have to buy iPhone, you have to buy MacBook, you have to buy a very costly clothes, you have to buy fare flight tickets, you have to buy at the same time everything. You have to buy flat in Bangalore, right? It is not possible, guys. Okay, having initial belief कि चलो you started making 50,000 rupees, now you are going to start buying, right? Okay, ऐसा कैसे होता है? Suppose you can think about it, right? Suppose you got a job right now, so some probability was there, you got a job, right? Now there will be a conditions, right? Your family is gonna show you, or somebody is going to show you, okay, just buy this, that. At the same time, you can't do, right? So you need to go into stages. First, you will buy something which is more important to make your livelihood better. ठीक है, तो हमेशा आप ऐसा ही करो, ठीक है, तभी आप लाइफ में हैप्पी रहोगे, अदरवाइज यू विल नेवर बी हैप्पी, ठीक है. So the first rule is what, guys? Multiplication rule. Multiplication rule. The second one is total probability theorem. And third is nothing but Bayesian analysis, or you can say Bayesian rule or Bayes rule or Bayes theorem. So we have to understand that where we are going to use these two theorems, right? Suppose any problem is asked, okay, suppose any problem is asked. So when you can say that, okay, when you can say that this is going to be used, right? And you can get the answer very quickly, right? That is also very important to identify in the problem, right? Because many people, what they do is they do not understand which rule we are going to use in this problem, right? Okay, because of misguidance or something. Okay, so ये बहुत important है. So multiplication rule, total probability theorem, you can say TPT, and Bayes rule. Based on this, we'll solve many problems, right? So these are important tools to understand conditional probability. So we will not do conditional probability at this moment. Just I've given you the introduction, right? That these are the topics that I'm going to discuss. So I will talk about the idea of conditioning, okay? Idea of conditioning, okay? And we will use some new information, and so that we can revise the initial beliefs, right? Whatever initial beliefs are there, some new information I'm going to use. जैसे मैंने मान लो बहुत साल पहले पढ़ाया कोई concept. Now I found some new concepts. So I'm just going to make my content new. Okay, some new information I'm gonna add here, right? So conditioning, the idea of conditioning I will talk. Okay, I think this is clear. So conditional probability is one of the very important concepts that I'll talk about. Okay, because in future conditional expectation also you will see so many things you're going to see, right? So I'll take some of the examples here. I will take some of the real life examples, okay, so that you guys can say yes, this is the idea. So we will see the conditional paradigm also, right? So whatever probability rule we have got, right, the similar probability axioms, you can say basic truth, are going to be shared with the conditional probability also, right? Like probability lies between 0 to 1. So for conditional probability also, that is going to be lying between 0 to 1. For sample space, probability of sample space is 1, or you can say probability of sure event is going to be 1. For conditional also similar story, right? So same concept are going to be useful, right? Okay, Fine. So let us take some of the type of the event. So type of the event, already we have discussed some of the events, right? So here type of events, right? Already we have discussed first event, that is mutually exclusive. Mutually exclusive. You can say this word is very useful, right? One of the friends recently visited to my Bangalore residence. So I said that he was from biology, I'm from mathematics, so we both are mutually exclusive, right? In fact, his way of life is also very different. Okay, so everybody has different lifestyle, right? So we were both mutually exclusive, right? There is no common, we are disjoint events. Okay, so that is what very important thing to understand. So mutually exclusive we have already seen, right? And yes, type of event way mutually exclusive, and second one you can say the impossible and sure event. Okay, third, okay, that is very important, simple and compound events. Simple and compound events. Simple and compound events. Okay, these are the events that you have to keep in mind. So what is the meaning of sure event? Sure event का मतलब क्या होता है? Sure event means the probability of sure event is going to be what? The probability of sure event, probability of sure event is going to be 1, and the probability of impossible event is going to be what? 0. So already we have seen these things, right? So I need not to discuss again, but I'm just revising. So you can say that simple event means if there is only one number of event, number of event is only 1, you can say. Number of events are 1, that is going to be a simple event. If suppose there are many, you can say many events, okay, in the question, so that is going to be a compound event, right? Like event A, event B, event C, so many events are given in the question, right? You will find in the question there are many events, so that says that is a compound event, right? The simple and compound event. What is the can we talk about, examples here? So let me give you the examples. Simple event versus compound event. Suppose any event is there, right? Suppose this is the event, head. Okay, okay, suppose you are tossing coin, and in the same, in two tosses you got head only, right? So this is one event, right? Okay, and suppose somebody is saying at least one toss, exactly two head. Exactly two head means head. Suppose they are saying at least one toss, at least one head, मतलब क्या होगा? There will be many events, right? You can say that the event is going to be like this: head tail, tail head, and head. So compound event means what? Like at least one head, you can say at least one head, and here exactly two head. So you will be able to identify that yes, this is a compound event and this is the simple event, right? So you can simply find out, right? So here you can say number of event is 1, but here number of event is what? 3. Number of event means how many elements are there in that event, right? So we have discussed about odds in favor, okay, of an event, and odds against. Okay, those things we have already discussed. So suppose we have to solve one problem here based on odds and all. Suppose example I'm taking, a pair of fair dice is rolled. A pair of fair dice is rolled. Guys, don't miss next class. Remember, next class is very important class. Agar aap next couple of classes, you can say, don't miss it, okay? Because those 3 rules are very important, right? To simplify all the concepts. So Pair of fair dice is rolled. Okay, now the question is find the odds against getting total greater than 9. Getting total greater than 9, right? Getting a total greater than 9. Okay, so a pair of fair dice is rolled. Okay, so what are the outcome that you're going to get, right, when you throw, or you can say when you roll a fair die? Fair means you're going to get 1 to 6, right? Okay, you will get 2, 3, 4, 5. Okay, like sum you're going to get, right? Sum. So find the odds against getting a total greater than 9, means sum should be 9 or greater than 9, you can say. So 6, 7, 8, 9, 10, 11, 12. So odd against means what? What is the meaning of odd against? Odd against means unfavorable upon favorable. Unfavorable upon favorable, right? Okay, it is not the probability, guys. Okay, this is the event, you can say. Odd against, right? Odd against means unfavorable upon favorable. Odds in favor means favorable upon unfavorable, and the probability is what? Favorable upon total. So in total there will be favorable as well as unfavorable, right? But while computing the probability of the event, you always take favorable outcomes in the numerator, right? That is the classical definition of probability, right? ये basic चीजें आपको पता होना चाहिए, right? So now you see how many times you will get this outcome. 1 time, 2, 3. Total कितने favorable हैं देखो यहाँ पर. Odds against getting a total greater than 9. Favorable is what? 1 plus 2 plus 3, that is 6. So here the favorable is 6. And unfavorable कितने हैं? You see unfavorable. How can we find unfavorable? You know the total. Total is what? 36. So unfavorable will be what? 30. So यहाँ से आप find कर लो. Unfavorable is 30 and favorable is 6. Answer will be 5. So in second you can solve this kind of questions, right? It will not take much time to answer this. So answer will be 5:1. Okay. So we have discussed equally likely and everything. So I'm not going to talk again, right? And mutually exclusive also we have discussed. Okay. Exhaustive also we have discussed. Fine. So guys, next chapter is going to be very important. Okay. Next, conditional probability, multiplication rule, and what? The Bayes theorem, right? You will come to know what is the meaning of Bayes theorem and where should we use Bayes theorem. Okay, so you have to wait for next, right? And after that, one of the important concepts that I'm going to talk about is I'll talk about independence. So let me introduce the concept of independence only. I will not give you the definition at this moment. I will talk about independence. ये independence बहुत important है for computer science also. Last year one question was there in computer science. Independence. Question of independence is very, very important. Question of independence. The independence of the two events, you can say independent of 3 events, right? So basically we are going to talk about types of event only, but these are the very important topic. That's why we are highlighting them. Independence. Okay, so there will be different types of independence. Okay, आप लोग केवल independence सुने होंगे कि हाँ दो events हैं, they are independent. See, disjoint events are different, independent events are different, remember. Okay, so if two independent, in future you will see that random variables are independent, right? Independent random variables, right? Okay, so what is the meaning of this independence? It has much more to talk about, right? So we will talk about different types of event. We will talk about independence. We'll talk about number one will be independence of two events, right? The second we will talk about here is conditional independence. Conditional. These topics are not taught anywhere, remember. Conditional independence. only you will find this kind of a topic at MIT or Indian Institute of Science if you go, or any top IITs, right? These local teacher, I mean, they are not local, they are, you know, global only. I mean, they are very popular teachers, but they do not talk about these things, okay? Because they don't want to revise their beliefs that whatever they have been teaching, that has become obsolete now, right? So according to the current trend, one should always change it, right? So these sessions are also for all the teachers, right? If they will be watching in future, ठीक है, कि ऐसे सेशन आप देखो कि आपको कुछ नया पता चले और बच्चों को बताओ, तरीका बताओ, नया तरीका, राइट? तो इंडिपेंडेंस के बहुत सारे कॉन्सेप्ट होते हैं. इंडिपेंडेंस ऑफ, देखो लास्ट ईयर इन द गेट एग्जामिनेशन इन कंप्यूटर साइंस वन क्वेश्चन वाज देयर, that question was from my notes only, whatever I teach, right? So you see, and it has some special name also. So independence of the two events, conditional independence, and then I'll talk about independence of a collection of events. Suppose there are many events, 3 events are there, 4 events are there. Independence of collection of an event, collection of the events, not event, and okay, and fourth one we are going to talk about. This is very important. This question was asked in the gate examination, the pair-wise independence, pair-wise. So we have to examine all those events which will be given in the question. So sometimes what happens, see, pair-wise independence and the independence of the collection of the, you know, collection of events, both are different things, remember, okay? Both are different, understood? It can happen that suppose there are 3 to 4 events in the question, right? So two events can be independent. So you will say pair-wise independent. But suppose you are finding the independence of all the events at the same time, like A, B, C, right? 3 events are there, and you are thinking that all 3 events are independent. Sometimes it is possible, sometimes it is not possible. So given the many events, right, okay, you can also say there can be what? There can be, you know, so this is very important to keep in mind, right? So if there is a compound event, like many events are there, number of events are more, so they can be pair-wise independent. Suppose A, B, C are the event, A, B, C. So A and B can be independent, right? B and C can be independent, A and C can be independent. But if you think that A, B, C are independent, so it is possible, it is also not possible, okay? So both concepts are different, right? In your gate examination, they will give you A event, B event, C event, and they will ask you in the options, A, B are independent, B, C are independent, C, A are independent. So it can be the MSQ kind of question, right? Multiple options can be correct also, right? So you have to examine each events, okay? And that is very, very important. So let me highlight this concept. ये पेयर वाइज इंडिपेंडेंट का कॉन्सेप्ट बहुत अच्छा है, इसको आप याद रखना. Conditional probability and independence concepts are very, very important, right? And then we'll talk about reliability also, okay? So in the application of independence we are going to talk about, we'll talk about the reliability, okay, application of this reliability, and so this is one of the application of the independence of the events, right? So we'll meet in the next session, guys. So let me know how was this session, right? Based on that, we will solve more problems, okay? So let me cover all the concepts first, then we will start solving the questions, right? So I think today's session was highly informative, right? So remember 2 things from today's session. One is the probability law. Second is the calculation steps that I have told you. And third is 3 important rules you have to learn in the next session. Fourth is the concept of independence. So conditioning, independence, all these things you have to realize, okay? You have to understand. So आज के बाद टॉपिक अपने माइंड में रखो, फॉर्मूला नहीं. अच्छे अच्छे टॉपिक रखो, ये जो अच्छे अच्छे वर्ड्स हैं, just keep them in your mind and enjoy them, right? So we'll meet in the next session, guys. Thank you so much for today.